Greetings, welcome to Self-Assessment 7, Problem 2. In this problem, what they're asking us to do is to evaluate a few of these logarithms. So I have found that probably the easiest way to get about these is to go in and actually think about them as an exponential first. In other words, use our definition and think about them from the exponential perspective, and then use that to help me decide what the logarithm is going to be. So for example here, what this is really asking me is it wants to know what is the exponent on a 5 that gets me back 1. And if you think about that, that's hopefully pretty straightforward, that if I raise 5 to the 0 power, then I get back 1. So in other words, the question mark here, or what I'm raising 5 to, is the 0 power. Same idea over here with logarithm base 3 of 1/3. If I think about that is, what is the exponent on a 3? In other words, what do I need to raise 3 to get it to be equal to 1/3? And hopefully after a little bit of thought, you think, well, 3 to the negative 1 gets me back 1/3. In other words, 3 to the negative 1 equal to 1/3 is an equivalent statement to saying the exponent on a 3 that gets me 1/3 is equal to negative 1. Okay, let's continue along with that line. So what is the exponent on a 2 that gets me back a 2? Well, if I raise 2 to the first power, I get back 2, so the exponent must have been a 1. In other words, what I raised 2, or that I got here for the question mark, that's what's going in right here. Excuse me, part D. What is the exponent on an 8 that gets me back 64? Well, I think if I square if I square 8, I get 64, so the exponent would be a 2. What is the exponent on a 5 that gets me 1/25th? So 5 to what power gets you back 1/25th? So if I take 5 and I raise that to the negative 2 power, that gets me 1 over 5 squared, which gets me 1/25th. So the proper answer here is negative 2. What is the exponent on a base 10 that gets me the cube root of 10? So a couple quick reviews here. First of all, recall that if we give you just log x, that's the same thing as logarithm base 10 of x. Those are identical. So if we leave the base off, it's assumed to be a 10. Second thing to recall is that the nth root of a is equal to a to the 1 over n. In other words, radicals are simply rational exponents. So just as an example here, if I had the cube root of 3, that would be 3 to the 1/3. Well, more relevant to what we're doing, if we had the cube root of 10, that's the same thing as 10 raised to the 1/3 power. So back at the ranch here, what we're asking is, what do I need to take 10 to? What power do I need to raise 10 to make it equal to 10 to the 1/3? And obviously, hopefully we see that the exponent would have to be 1/3. Okay, so hopefully these are all pretty straightforward for you. If they were not, please do not be shy about posting questions in the Q&A forum, and I or one of your fellow students will get back to you as rapidly as possible.